You have to now apply what we've done. So start and see what the answers are. It's short answers. You just have to underline in brackets the correct one, but you have a lot of thinking to do before you get the right answer. So it's now over to you to do that questions. So the temperature is increased, and if the temperature is increased, Le Chatelier tells you that you suppose the system will react to decrease the temperature by favoring the endothermic. Then you check the delta H, which tells you forward is exothermic, and therefore this means you have to favor the reverse. Right, and if the reverse reaction is favored, your products will be less, your reactants will be more, and therefore your Kc value will be less as well. And that's why the answer was decreased. Right, with the second one, let me just give you a hint. You are going to do it on your own, but with the second one, they are only drawing the rate of the forward reaction. So maybe it will be easier for you if you go and draw the reverse reaction in. The reverse reaction would have been da-da-da-da-da-da. Okay, and here it's a temperature change. What do we know about temperature change? Both should go up a little bit. Huh? And then the one should be like that and the other one like that. Right, so go on from number 2. The answers were increased and increased. Right, let's check this one. They said a mixture of NO and Br2 is placed in a container and the reaction occurs. And then they say after 10 minutes, I actually think that should be something like 10 minutes, right? Equilibrium is reached and then something is changed. Now, they say at 15 seconds, what is happening to the temperature? Now, go to your graph. How is your graph going to tell you if the temperature increase or decrease? The fact that the rates are going up, right? So your graph will tell you that the rates are increasing, and that should tell you this was an increase in temperature. So that's the first thing you had to get. It's an increase in temperature, and I know it because the rates are going up. If it was a decrease, they should have gone down. So it's up, therefore it's an increase in temperature. Then they asked me about the Kc value. Now, Kc value depends on my products, it depends on which reaction is favored. So go back to my graph. What does that part of the graph tell you? Which one is at the top? Forward is at the top. So my graph tells me that the forward reaction was favored by whatever change in temperature I did. Right. Now, if the forward reaction was favored by an increase in temperature, what do I know? What type of reactions will be favored by an increase in temperature? If temperature is increased, Le Chatelier tells you, the system will try to decrease. It will favor the endo. So what did I do to favor the endothermic? I increased the temperature, then the system tried to decrease. What's happening to the Kc value? Sorry, that was not even necessary. Hey? You only had to say forward reaction is favored, so what's happening to the products? Increase. Forward reaction is favored. What happens to reactants? Decreased. So it's not even necessary to think about Le Chatelier. Right, so don't even go there. Right, everyone that's happy, go on with 3. For those who are still a little bit stuck at 2, let me just do it again, slowly. They say you've got a mixture in the container, equilibrium was reached, and now they ask you, at 15 seconds, was the temperature increased or decreased? And the way to know is to see what's happening with the rates. If the rates go up, it can only mean the temperature was increased. So that's how you know about the temperature. And then they want to ask about the Kc value. And with Kc value, you have to know what happens with the products and reactants, and that you get from which reaction is favored. So you go back to the graph, which one is at the top, which has got the higher rate values? The forward one. So if the forward is the higher rates, then it will produce more products and you will end up with a bigger Kc value. Right. Go on with number 3. P and Q are in a sealed container and the follow chemical reaction is reached after 5 minutes. So you've got equilibrium there. Then after 10 minutes, the temperature is increased. So there's the first important thing. They are increasing the temperature. Right, what do we know about an increase in temperature? If I increase the temperature, according to Le Chatelier, the system will try to decrease the temperature by favoring what? Yes, nice. By favoring the endothermic one. So this is one part of information that they give you. They tell you it's a temperature increase. Right. Then we go to the graph. What does your graph tell you? Now this time they didn't draw rates. They drew P. Where's P? P is over there. And this is very important. They're talking about P. What's happening? You're doing something over there with temperature. We don't know what. Oh, they're telling us increase. Okay. But you're doing with temperature something at that moment, and now the system is reacting. And when the system reacts, that reaction makes the P become more. The P is increasing. So which reaction was favored? The reverse reaction. So that is what you have to get from the graph, and that is the difficult one, right? They're telling you P is increasing. Why is P increasing? It's not at that moment. It's afterwards when the system reacts. Right, I do something, and now the system reacts, and what the system does makes my P become more. So the system is favoring the reverse reaction. And then you say, okay, but they're talking about the same thing. So that tells you that reverse is endo. And therefore the forward is exo. And therefore delta H is negative. Right. And for Kc value you have to look at products and reactants. P is a reactant. It is increasing. So the products will be decreasing. So my Kc value is decreasing. So you have to be able to do a lot of steps, and you have to be able to formulate and think in reverse. This is what the system does. Why does it do it? What happened before? You have to be able to work back. Right. Okay, let's do quickly number 4. Can I see how many of you are finished with number 4? Right, I think it's an easy one. Let's do it together. Right. In the following reaction mixture turns, there's the first clue. More red when the temperature is increased. More red when the temperature is increased. Okay, you look at the reaction. Remember, this happens because the system is reacting. Why is the system reacting? Because of something I did before. Right. If it turns more red, what does it tell you? It tells you the forward reaction was favored. And that produces more red ones. That's why it looks more red. Right. But an increase in temperature, according to Le Chatelier, will always favor. If I increase the temperature, the system wants to decrease the temperature, and it favors the endo. So immediately you have two things about the same happening. So if forward is favored and endo is favored, then obviously forward is your endothermic. And that makes your delta H positive. Right, so that was positive. Okay, and they're also asking you, when the temperature is increased, what's happening to the Kc value? Kc is products over reactants. If it's more red, it tells you the forward reaction is favored. You've got more products, less reactants, bigger Kc value. So the Kc value increased. Right, 5, 6, and 7. Let's see how you do. So let's look at 1.5. The following reaction reached chemical equilibrium in a closed container. Okay, everything fine. What does delta H smaller than 0 tell you? Forward exo. Right. And now they say at time x, the temperature was, and now they want to know increase or decrease. Now, they didn't give us rate graphs. If it was rate, it was easy, because rate going down, temperature down. Rate up, temperature up. But they give us H. Now, the important thing is, where do you find H? H is a reactant. It's on that side. So what is happening to H after the change at X? After the change at X, H is decreasing. What does that tell you? That tells you that the system favored which reaction? The system favored the forward. Right, the forward reaction was favored. Right, the forward reaction was favored. And they say it is, the forward reaction is exothermic. So what do you have to do to temperature in order to favor the exothermic? Exo produces energy, right. So you must decrease the temperature, which will make the system, according to Le Chatelier, try to increase the temperature by favoring the exothermic one. So this was difficult. You had to know how to do delta H, and then you had to know the fact that H is decreasing tells you forward is favored, and you can only have the forward, the exo favored by lowering the temperature. Right, so the first one was decrease. Right, and then they ask you about the Kc value. For Kc value, products over reactants, and what do you know about your reactants? H is a reactant, it's decreasing. If that one is decreasing, then obviously that one is increasing, Kc value increases. Right, 1.6. Come on, guys, you can do it, I'm sure. Come on. The following reaction equilibrium, green and blue. Temperature increases, turns more blue. Temperature increase, according to Le Chatelier, the system will try to decrease that by favoring endo. Right. And then it turns more blue. If it's more blue, it tells you forward is favored. Right. So forward is actually endothermic. And therefore delta H is positive. Right, can I see how many positives were there? It's good. It seems you feel positive about equilibrium. Hey. Right, very last one. Now here again they gave us rates, right? Rates. And they tell us rates, and they say the Kc value is smaller or bigger after time x. Now, what's happening after time x? Which reaction is favored? Where will the other one be? If I had to draw in the other one, it would have been like this. Is that right? So this tells me that the forward is actually the one with the bigger rate. The forward is the one that is favored. Right. So forward is favored. And if forward is favored, what's going to happen with my products? More, and reactants is less. So my Kc value will be bigger. So the first answer was larger. Right. And then they ask us about delta H. Now tell me, if the rates decrease, what does that tell me about the temperature? Your graph shows you that the rates of the reactions decrease. It's going down. And it will only go down if the temperature went down. And if the temperature went down, then Le Chatelier should have said, we are trying to increase by favoring the exo. Right. So the exo form is favored, but from the graph, we can see the forward is favored. Hey? So forward is actually exo. Forward. And therefore, delta H, negative. Negative. So these are really the difficult questions that you get with equilibrium.